Let's try to figure out how to find limits of piecewise function. Okay, so we'll do a few examples. This is one of them. And let's say a piecewise function is defined by f of x is equal to, let's say, minus x minus 2 if x is less than or equal to minus 1. And let's say it is equals to x if x is between minus 1 and plus 1. And let's say it is equals to x squared minus 2x if x is greater than or equal to 1. Okay, so that's a piecewise function, right? So first thing is, it's better if you can sketch your function, right? So let's try to sketch our function. Okay. Now when you're trying to sketch the function, look for the points where there could be discontinuity, right? So you have split the domain into parts from minus infinity to minus 1, and then from minus 1 to 1, and then from 1 to infinity. Okay, so these are our sections. We can say this is one section, right, which is from minus infinity to minus 1. Let me write minus 1 here, and then we have from minus 1 to plus 1, right, and then we have plus on that side. Okay, so let's write down this section as minus 1 here and plus 1 here, correct? And this of course is 0 for us, and this is x and this is f of x, correct? And now let's try to sketch our function, right? We say that f of x is minus x minus 2 if x is less than or equal to minus 1. So when we say minus 1, so the extreme value is minus 1. If I plug in minus 1 here, then what happens to f of minus 1? So minus of minus 1 becomes plus 1, and plus 1 minus 2 is minus 1. So at minus 1 I get a value which is minus 1, and this value is filled up, right? So that's the value minus 1 which I get here, correct? Now if it is between minus 1 and 1, it is the x value. So at minus 1 you get a hole, and the value of hole is minus 1. So it coincides with this. Do you see that? So let me write this in different color, and just let me show you that this is for the other function as a whole, but you know, we filled it already. But at 1 it is again x. So at 1 it is 1, and let's say this is my value at 1. Okay, so this is for my this value, correct? So I got these two holes, and as it is a straight line, it gets connected in between. So at 0 it is 0, right? So it gets a line which is connected like this between here to here, correct? So well, this is not a hole, this is filled up. 0 I could have written here, right? Let me write 0 here, correct? Okay. Now the last one is a quadratic function which is greater than or equal to 1. So if I plug in 1 here, in that case, what happens to this? If I plug in 1 there, then 1 squared is 1 and minus 2 is minus 1. So at 1 I have a value which is minus 1. So I'll have a filled up value here which is minus 1 at 1, correct? And as it goes higher and higher, right? So basically if I want to find, if I write 2 here, then 2 squared is 4, and 4 minus 4 is 0. So at 2 I have a 0, right? And it's a parabola, and it's going to increase in step of 1, 3, 5, 7, correct? So first step is 1, and then the step will be 2, 3, right? Kind of like this, right? So I can always draw this parabola which is kind of like this. Do you see that? Right. So I got this part of the graph, correct? Now let's go back to the first part. When x is less than minus 1, then we found out that it was minus 1. Now how about the other values? So the other values, let's take some other example. Minus 2. If x is minus 2, then minus and minus becomes 0, and minus 2 minus 2 plus 2 and plus 2 minus 2 becomes 0. And so at minus 2 we have an x-intercept, right? So basically this is a straight line, so what we can do now here is join the straight line like this, correct? So this part is in red, right? And this part is in orange, correct? Now, so these are three pieces joined together, correct? And now let's look into the question, what are we asking for, correct? So we say, what is, now here, let me do it right here for you under this diagram. Let's try to find out limit of the function as, we can say here, limit of the function f of x as x approaches -1. So let's say you have to find this first, right? And you are also supposed to find limit of the function f of x as x approaches 1. Well, these are two interesting points because the pieces are joined together at these points, correct? So let's look into what happened to our function at these points, right? Now, at -1, we see one thing, that when we approach from the left side, so in both the sides, we have to see what happens as we approach from the left side and for the right side, correct? If we approach from the left side, so that means what we are trying to do is we are trying to find limit of f of x as x is approaching -1, but from negative side, the left side. So this is our left side limit, right? Let me write here the left side, okay? So we are trying to find left side limit, okay? So as we go from -1 left side, that means you're lesser than -1, then you'll follow this equation, correct? If I plug in -1 here, so it becomes +1 minus 2, which is equals to -1, correct? So here you get a value which is equals to -1, correct? Similarly, let's try to find the limit of f of x as you are approaching -1 from positive side. That means from this side, right? So when you approach from this side, then this is the relevant equation, right? Because you're on this side, that means this part of the piece. So you are approaching a value which is equals to the same value, and which is -1, correct? So in both cases, we find that this is left and this is right side limit, right? So left side limit and right side limit both are -1 and -1 since they are equal, correct? So we say limit of the function here at 1 exists, and this is equal to -1. Do you understand the concept? So at this point also you can see from the sketch that the limit exists and its value is -1. So we are approaching from this side and we approach a value of -1 at x equals to -1 from both the sides. Now let's try to analyze the second limit, which is limit of the function at x as x approaches 1, right? Clearly you can see when you approach from the left side, so we'll again do the same thing here, right? So we say, let's say limit of f of x as x approaches 1 this time, but from the negative side. So when you are approaching 1 from the negative side, you are approaching a value which is +1, correct? How about limit of f of x as x approaches 1 but from positive side? That means when you approach from this side and come closer and closer, you actually land here, which is equals to -1, right? Since these two limits are not equal, we say the limit of the function f of x as x approaches 1 does not exist. Do you understand the concept? So we say since left side limit is not equals to right side limit, right? We say that limit of the function, we say limit of function f of x as x approaches 1 does not exist, correct? They have to be exactly same for limit to exist, correct? Now here we'll say limit f of x as x approaches -1 is equals to minus 1, since both are equal. Do you see that? So that's the kind of difference which we get in both the places. You should have a good look at this and see how we found all this. Apart from these points, if I say find the limit at any other point, let us say if I say find the limit at, we find, say, let's say limit x approaches, let's say, a value 2 of f of x, right? Now at 2, you are falling into this region, correct? Here. So you will plug in 2 in this place, and you say because the function is continuous, this is basically equals to f of 2, right? If you plug in 2 here, you get 2 squared is 4, and 4 minus 4 is 0. So that's the point. So which is equals to 0. I hope you understand this is f of 2 is 0, right? Any other point which is on the continuous part, it will be the value of function at that point, because you approach to that point and it is continuous during that period, okay, of interval, correct? So that is how you should do the piecewise functions. So in a piecewise function, first thing is, if possible, sometimes the pieces are too difficult to manage, but most of the time they're simple enough. So try to figure out the extreme values of your intervals where the pieces are getting joined together, and then sketch a graph. Once you sketch a graph, things are very clear. The question was limit of f of x when x approaches minus 1. So when you are approaching minus 1 here, from this side or this side, you are getting to value which is minus 1. So limit exists. But when you approach this function at plus 1, so when you are approaching plus 1, you see a break there. This type of discontinuity is called jump discontinuity. So let me mention here, we have a jump discontinuity. Okay, so at times in the question they also ask define the type of discontinuity. Since the limit exists and the limits are different values, we have a jump discontinuity. Well, we could have infinite discontinuity if it was going to infinity, right, at that point. But in this particular case, it is a jump discontinuity, right? So I hope this clears your thought about how to find limit of piecewise function. We have a couple of more examples here, so you can look into those examples also. I hope it helps. And in case there are some doubts, put in your comments and then we'll get back to it. Thank you.